Hello students, in this video I will discuss numericals in chromatography. So you need to remember some formulas to solve the numericals for M.Pharmacy Modern Pharmaceutical Analytical Techniques. The first formula is capacity factor. Capacity factor is given by TRB minus TM divided by TM. Here TRB refers to retention time for the analyte B. TM is dead time or the retention time for the unretained component. Second formula is selectivity factor. If there are two analytes, A and B, the selectivity factor is calculated by using the formula TRB minus TM divided by TRA minus TM. Here TRB refers to retention time for analyte B, TRA refers to retention time for analyte A. Next formula is number of theoretical plates. Number of theoretical plates is given by 16 TR by W whole square. Next formula is resolution. Resolution between two analytes A and B is calculated by using the formula 2 multiplied by TRB minus TRA divided by WA plus WB. Here TRB is retention time for the analyte B, TRA is retention time for analyte A, WA is width of the peak for analyte A, WB is width of the peak for analyte B. So if you remember these formulas, you can easily solve the numericals. So there are four formulas. First one is capacity factor, second is selectivity factor, next number of theoretical plates, next resolution. So let us solve the problem. So this problem is given in the university exams. See the problem. It is chromatogram shows an unretained solute eluting out at a dead time of 1.2 minutes. So dead time corresponds to TM. The value is given is 1.2 minutes. There are two more analyte peaks observed. Peak A starts at 3.5 minutes and ends at 3.8 minutes, while peak B starts at 5.7 minutes and ends at 6 minutes. Assuming that peaks A and B are symmetric, calculate adjusted retention time for peak A, capacity factor for peak B, selectivity factor, number of theoretical plates for peak B, resolution between peaks A and B. So let us solve the problem. So the first question is adjusted retention time for peak A. So the values given are dead time is given. The value is 1.2 minutes. Retention time for peak A you can calculate by using this formula. So this is the time at which the peak is starting and at 3.8 minutes the peak is ending. So add these two values and divide with 2. So the value retention time for peak A is 3.65 and retention time for peak B you can calculate using this formula 5.7 plus 6 divided by 2. It is 5.85. Peak width. For peak analyte B, the width of the peak is subtract 5.7 from 6. Then you will get the width of the peak for peak B. The value is 0.3 minutes. So adjusted retention time is calculated by using this formula. Adjusted retention time for peak A is 3.65 is the retention time for peak A minus dead time. The dead time given is 1.2 minutes. So 3.65 minus 1.2, the value is 3.45 minutes. Capacity factor for peak B, it is calculated by using this formula. This is retention time for the analyte B minus TM. TM is nothing but dead time or retention time for the unretained species divided by TM. The value is retention time for analyte B is given. So this is 5.85 minus 1.2 divided by 1.2. So this is the answer for capacity factor for peak B. Next, selectivity factor, the formula is TRB minus TM divided by TRA minus TM as we discussed. So TRB corresponds to retention time for analyte B. The value is 5.85 minus dead time, it is 1.2 divided by, this is retention time for analyte A minus TM dead time. So the value is 1.89. Next, number of theoretical plates for analyte B is 16 TR by W whole square. So for analyte B, the retention time given is 5.85 minutes. So 5.85, 16 multiplied by 5.85 divided by 0.3. 0.3 is nothing but width of the peak. So here width of the peak is 0.3. Width of the peak is 0.3. So the answer is 6084. Next, resolution between peaks A and B. If this is the formula, so substitute the values in this formula, you will get the resolution between peaks A and B. Retention time for B minus retention time for A. Substitute these values here. Width of the peak A and width of the peak B. Peak B width is 0.3. So in the same way, peak A width is also 0.3 because the peak is starting at 3.5 minutes and it is ending at 3.8 minutes. So 3.8 minus 3.5, that is 0.3 minutes is the peak width for peak A. So we solved one problem. The second problem is compound X was analyzed on two different columns. So we are analyzing the compound on two different columns. Retention time of X when analyzed on a 15 centimeter column was 15.3 minutes and width of the peak was 0.82 minutes. So width of the peak is given, retention time is given. And when the same analyte is analyzed on a 30 centimeter long column, the retention time was 24.7 minutes. Here the retention time is 24.7 minutes and width of the peak is 0.96 minutes. So calculate the number of theoretical plates for each column. Number of theoretical plates for each column. Justify which column is more suitable for analysis. So answer for this problem is column length is given, retention time is given, width of the peak is given, number of theoretical plates, it's given. So number of theoretical plates for the first column, number of theoretical plates for second column is given. So calculate the height equivalent to theoretical plates. It is length of the column divided by number of theoretical plates. So length of the column is 15 divided by number of theoretical plates. It is 5570. The value is 0.00269. For the second column, length of the column is 30 centimeters and number of theoretical plates is 10,591. The answer is 0.0028. So the column length, which is a column of length 15 centimeter, it is more suitable for analysis because HETP is less for the first column. So it is more suitable for analysis. The answer is first column is more suitable for analysis or the column having length 15 centimeter is more suitable for analysis. Just check the question again. So calculate the number of theoretical plates for each column. So after calculating, we got the number of theoretical plates as 5570 and 10591. So and justify which column is more suitable for analysis. So how to calculate number of theoretical plates? Here the number of theoretical plates is calculated by using the formula 16 TR by W whole square. Here the retention time is given and also width of the peak is given. Simply if you substitute these two values, you will get the N value for 15 centimeter column and also N value for 30 centimeter column. The formula is 16 TR by W whole square. Here the retention time is 24.7 minutes TR value and W value is 0.96. Next, last problem. Compound X and Y were analyzed by RPHPLC using a column of length 30 centimeters. An unretained species eluted at 1.3 minutes. So this is the time for the unretained species, or you can call it as dead time. It is denoted by Tm. The retention time of X and Y were found to be 6.6 and 8.1 minutes. The peak width at the base are 0.97 and 1.2 minutes respectively. Calculate the resolution for species X and Y. Calculate the number of theoretical plates for compound Y. Justify whether calculated number of theoretical plates and resolution can be accepted or not. So first we need to calculate the resolution between X and Y and also calculate the number of theoretical plates for compound Y. Answer is, so these are the values given in the problem or numerical. Time for the unretained species, it is 1.3 minutes. Our dead time is 1.3 minutes. Retention time of X is 6.6 minutes. Peak width for X is 0.97 and the retention time for Y is 8.1 minutes. Peak width is 1.2 minutes. Use this formula to calculate the resolution. Resolution is calculated by 2 TRY minus TRX divided by WX plus WY. TRY value is given. It is 8.1. Retention time for analyte Y. This is second. TRX is retention time for analyte X. It is 6.6. So substitute in this equation. This is width of the peak for analyte X and width of the peak for analyte Y. 0.97 plus 1.2. So you'll get the answer. Resolution 1.38 and number of theoretical plates is obtained by using this formula 16 TR by W whole square. So we are calculating for the compound Y. So the retention time for Y is 8.1. You can see here. Retention time for Y is 8.1 and peak width is 1.2. So you got the value like 729. Number of theoretical plates should be greater than 2000 and resolution should be greater than or equal to 1.5. But number of theoretical plates we got here as 729. So calculated number of theoretical plates and resolution cannot be accepted. So this is about numericals. Thank you for watching the video. And if you like, please like, share and subscribe the video.